Hello, math students. We are still working in Module 1 called Ratios and Proportional Relationships. The title of this lesson today is Finding Equivalent Ratios Given the Total Quantity. Finding equivalent ratios given the total quantity, and this is lesson 10. The goal for today. Today we are going to learn how to find equivalent ratios in tables involving fractions. Oh, more fractions. Okay, well we can do this. The question, how can a table help you find the total quantity? So we're going to keep that in mind because this lesson, this is one sheet. That's it. Nothing else. Okay? And so we're going to look at how the table can help us figure this out. So things to know. A quantity table is just like a ratio table, but it has more than one column. So if you look at it, we have the x values and the y values, but we put one more column on there, and that is going to be the total column. So here's your input. Remember we talked about this a long time ago. The x value is the input. It is the independent variable. It is the amount that does not need anything else in order to exist. So this is the input side, or the independent variable. We talked about that in an earlier lesson, independent amount or variable. Okay. Whereas the output is the dependent variable. And the reason why it's a dependent is it cannot exist without the x value. And the reason why we talk about it cannot exist without the x value is because we have to do something to the x side, and we usually have a rectangle right here. Remember, it's called our constant. So we're doing something to the x value to get the y value. So this y value can't exist if something doesn't change the x, okay? I'm trying to get you to remember that. Okay, so basically, it says we have a column for the x value, a column for the y value, and a column for the total. And you see them right there. Okay? All right. So what our job is we're trying to figure out what is the constant so that we can then figure out what the total is. Or if we know the total and we know the output, then that means something plus this gave us this. So our job is to figure out what this is in order to find it. Okay, so as you can see, this one right here is missing. So what we're going to remember to do to figure out this table is we're going to use what we learned a couple of lessons ago, and that was in order to find the constant, we always remember we take y divided by x. So the y value in this table right here is 3/4. That's the y. It says y right there. This is 1/2, and it's the x value. So if we remember y divided by x, so y is 3/4 divided by x, and x is 1/2, then we have, just like in our last lesson, a fraction divided by a fraction. And we learned the rule. The rule was that you're trying to find a common denominator. So the first thing that we're going to do is we're going to set up our common denominator. And we're looking at 4 and we're looking at 2, and automatically my brain says, oh, well, 4 is the best common denominator that you can have. So here is 4, here is 2. Now I have to ask myself that age-old question, how did I get from 4 to 4? And it's times 1. What you do to one side, you have to do to the other. So 4 times 1 is 4, 3 times 1 is 3. So that one stayed exactly the same. And now I have to do this one. And I ask myself, how did I get from 2 to 4? And I remember that it's times 2. What you do to one side, you have to do to the other. So 2 times 2 is 4. And 1 times 2 is 2. And now, kiddos, look what I have. I have a division problem. So I'm going to put equals, and I'm going to write 3 divided by 2 is 3 divided by 2. 4 divided by 4 is 1. So my answer for this one is 3/2 per 1, right? We learned that yesterday. Okay, well that right there is my constant, because remember the constant is the unit rate. And the unit rate is per 1. And we just found per 1. So my constant for this problem has to be 3/2. So up here, I am going to write times 3/2 times 3/2 times 3/2, because I already know that that's my constant, okay? So that's why we make our table, because our table tells us what we're supposed to do. Okay, so that wasn't so hard. So that means that I took 1/2 and I times it by 3/2, and if you look at it, watch, 1 times 3 is 3. 2 times 2 is 4. Ta-da! It worked. You found it. Okay, and then the last thing that we have to remember about this process is to get your total. What did we have to do? Well, what you have to do is you have to remember this is an addition problem because x plus y gives you the total, right? So x plus y equals total. So 1/2 plus 3/4 equals what? Well, we learned a long time ago that in order to add fractions, you have to have a common denominator. So 1/2, right, plus 3/4 is the same thing as, common denominator rules, come on. Okay, so I have 2, the common denominator between 2 and 4, I would say is 4, so we're going to put 4s as our denominator. Then I'm going to remember my little rule of 2 and 4. How did I get from 2 to 4? I times by 2. What you do to one side, you have to do to the other. 1 times 2 is 2. So now this one is 2/4. How did I get from 4 to 4? You are correct. So I times by 1. What you do to one side, you have to do to the other. So 3 times 1 is 3. 4 times 1 is 4. Now I have a common denominator, and I can add. So common denominator stays the same. In adding, you don't add the denominators when you're adding. When you're multiplying, you multiply them straight across. Divide them straight across. But adding, they stay the exact same. I know that's a little tricky. 2 plus 3 is 5. And so my answer of 1/2 pound plus 3/2 pounds is actually 5/4 pound, which is the same as 4 goes into 5 one time. 5 minus 4 is 1, so my answer is 1 1/4 pounds. And that's my total. Okay? Wow, that was a lot. But not horrible. Just you got to remember all the steps. Okay, so now our next job is we've got to figure out how much dark chocolate we had. Then we multiplied it by 3/2 and we got 1 2/4. Well, for this old lady brain, the best way for me to do that is I've got to turn this into an improper fraction so I know what I'm working with. So let's draw it. I want to show you this. This is kind of awesome. So I'm going to use this pen because it says 1 2/4. So that means I have one hole, right? Tape diagram, one hole, and then I have 2/4 of the next. So what this looks like is I have the colored part. Okay, so here's what I have. All right, I have one hole and 2/4. Do you see it? So now all I have to do to make this a fraction, not a mixed number, but a fraction, is I go, I have 1 2 3 4 5 6. I have 6/4. That's what I have. Okay, and if you use your old check and balance ways, you go 4 times 1 is 4 plus 2 is 6, so I have 6/4, and it works. Okay, so now remember, we had to take something times 3/2 to get 4. Well, look at that. What would be the number if I have a 6 right here and we're multiplying straight across right here? Remember this. This is a 6. And then I took a number times 3 to get to 6. What number times 3 gets to 6? If you said 2, you're right. Look at it. 2 times 3 equals 6. Well, that's not so horrible, right? Okay, so now let's do the bottom one. You had to take something times 2 to get 4. Well, what did you have to do? Well, I know that 2 times 2 equals 4. Holy moly, check that out. That's lovely. 2 times 3 equals 6. 2 times 2 equals 4. So my constant has to be 3/2 because we already figured that out. So the amount of dark chocolate that I started with was 2/2. Well, 2/2, guys, is really 1. What's 2 divided by 2? You get 1. Oh my goodness, check it out. So you have 1 times this, and you get 1 2/4, which is actually 1/2. Dun da da da! Light bulbs! Okay, let's check it because they gave us the total over here. Let's see if we're right. So we're going to take, remember what we did, we're going to take this guy right here plus this guy, and it should equal that guy, remember? So we're going to take 2/2 plus 6/4 equals, but remember we have to have a common denominator, so we're going to do the common denominator, 2 and 4, so we're going to say 4 is the common denominator, and we're adding them, right? Okay, so now I take this guy and this guy, and I ask myself, how did I get 2 to 4 times 2? What you do to one side, you have to do the other, so this one is really 4/4. Not bad. And this one is, how did I get from 4 to 4 times 1? What you do to one side, you have to do to the other. 6 times 1 is 6. So now I have, are you ready? Here we go. 4 plus 6 is 10/4. Okay, hold on, we're not done. How many times does 4 go into 10? 2. What is 4 times 2 is 8. So what is 10 minus 8? You have 2 leftovers, right? So you have 2 2/4, which is the exact same thing as 2 1/2. Check it out. 2 1/2. It's right there. We found it. Okay? So that's not horrible either, right? Okay, we're down to the last one. Think you can do it? I think you can. I believe in you. This one's the easiest. Look. All we have to do is multiply across and we should get the right answer. Yahoo! Okay, let's do it. What is 6 times 3? Well, not too awful. 6 times 3 is 18. Yeah? What is 8 times 2? 16. Well, that's not horrible. So now we just turn that into a mixed number because these are mixed numbers up here, right? So 16 can go into 18 one time, and then 18 minus 16 is 2/16 left over, which simplifies to 1 1/8. Okay? So now our job, to make sure we remember what we were doing, you take this amount plus this amount, and you should get that amount. Well, if you want to do it the easiest way, for me, would be draw it, 6/8. Okay, here is, right, those are now 8s, and we have 6 of them. So 1, 2, 3, 4, 5, 6. We have 6/8 plus, right, this one up here is 1 1/8. Okay, so we have to do this, right, and this, right, and we have 1 whole 1, so that means everything in here is colored in, right? And then it said 1 1/8, so I have to draw one more. See how pictures are so helpful? And we only have 1 out of the 8 there. And then, what does that equal? So I have all of this, so that's 1 whole, right? Except I'm running out of room. That's the only problem with drawing pictures, is you run out of room really fast. But we know that we have all of that. And the reason why we know we have all of that is because it's sitting right there staring at us. Okay, look at it. We have all of that. Ooh, you can't even see me doing this. So we have all of this. This is, okay, let me show you again. 6/8 right there, plus 1 1/8 right here, and now we're finding the answer. So we have 1 whole, which is this guy, and now count what we have. We have 1, 2, 3, 4, 5, 6, 7. And so we have 7/8 right here. So again, pictures are beautiful. And it said 1, 2, 3, 4, 5, 6, 7. So I have to color in 7 of these guys. 2, 3, 4, 5, 6, 7. So our answer is 1 whole and 7/8. Oh my goodness, guys. Did we find it? Hallelujah! Hooray, hooray, hooray. You found it. Okay, my darlings. Wow, that was a lot of math, and it was only one piece of paper. So, but I think you're okay. I think you've got this. Okay, so let's go back up to our goal. Today we are going to learn how to find equivalent ratios in tables involving fractions. Please do not let the fractions scare you. Just go slow and use pictures and write it all out. Question, how can a table help you find the total quantity? The answer to that question is it helps you organize it. It helps you make sense of it because you know that the x value plus the y value is going to give you the total value. So if you remember that, then you won't get lost. The other thing that is so important to remember about our table is finding your constant first, because the minute we found our constant, everything else was very easy to do. Okay? All right, kiddos, that's all I have for you in this lesson. I'll see you later. Bye!